Welcome to Make Made Simple. Today we will be doing another example on direction of friction force, and the example number is example number 2. So there are two masses kept over a surface and they are attached over a pulley which is attached to the wall. Then nu of 1 and nu of 2, nu s of 2 between these two surfaces are given here, and we are also given the force applied at m1. So this arrangement will move like this. A acceleration will be in this direction, acceleration will be in this direction, and we are given the force F is 100 Newton, m1 is 5 kg and m2 is 3 kg. We have to find the friction force on m1 and friction force on m2 and also the acceleration of the system. So we'll first start by drawing the free body diagram. So we have this m1g acting downwards, m2g acting downwards, m2g acting downwards. Then we'll have a normal reaction n1 will be in this direction, which will be equal to m1g plus m2g. And we'll have another normal reaction given by this surface here, which will be equal to m2g. n2 is equals to m2g. Then after that, the frictional forces that are acting on these blocks are as follows. One frictional force, if this is moving in this direction, then the frictional force will be in this direction. FFR1. Then we'll have a friction force. This is moving in this direction, so we'll have a friction force here. And the friction force will be in this direction. Because this is moving in this direction, so a friction force will be in this direction. So this is FFR2. And this would be FFR3. So we have three friction force in to be taken into account: FFR1, FFR2 and FFR3. So these three are friction forces. Now what is FFR1? FFR1 is m1g plus m2g nu 1. m1g plus m2g nu 1. This is F frictional force 1. So what is FFR2? FFR2 will be equal to N2 nu 2 N2 nu 2 equals M2g nu 2. Then we have found the two friction forces, and friction force 3 would be, I'll write it here, FFR3 equals, or I'll write it here, FFR3 would be equal to M2G nu2. So these are our three friction forces magnitude. Now we have to take the acceleration. What is the acceleration of the system? So we have A equals now we have to calculate the acceleration of the system. So acceleration equals to F net by mt, that will be equal to FAD minus F opposing, F aiding minus F opposing by mt. So we will have A equals to so there is only one aiding force, that is F. So I'll write here F minus, we have one frictional force 1, that is this one, M1G plus M2G nu1, M1G plus M2G nu1 minus M2G. Second frictional force is F frictional 2 and third frictional force is F frictional 3. So we have M2G nu2 and M2G nu2 two times. So I'll write it here, two times M2G nu2 divided by whole mass M1 plus M2. Now I'll put the values. So we have the values here, 100 minus M1. M1 is 5 kgs into 9.8 plus M2 is 3 kg into 9.8 into new one is 0.2 plus no minus, this should be minus 2 times M2 is 3 kgs into 9.81 into nu2 is 0.3. So this is our acceleration, whole divided by 5 plus 3. So this will be equal to, if we calculate this will be calculated as 8.3 meter per second square. So this is the acceleration value. and answer 1 is this, and answer 2 is friction value of M2 is this one. So we have got all the answers here. So that was all for today. You can check out the board here to write down your notes. So if you have gained some knowledge from this video, please do like the video, subscribe to my channel and share it among your friends. Thank you.